Okay, go. I would like to welcome all of you to today's lesson. First, I'll start with a short recap of what we covered last time. Then I'll proceed to look at views, which is the second part of this chapter. Last time we did start looking at this chapter, which looks at implementing indexes, views, and full text search. And I did explain that we are mainly going to focus on indexes in this first part. Then we'll look at views in the next lesson. We did explain a few things about indexes as far as SQL Server is concerned. We said that indexes are used for a number of reasons in SQL Server. Primarily, the SQL Server will allow you to create indexes on tables to enable you have quick access to information stored in the tables. So the first reason for implementing indexes is to ensure that users of the database are able to quickly access data that is stored in the database. Sometimes you need to view and control the execution of queries. So SQL Server provides a means for you to not only view the plan, but also control the execution plan. Then SQL Server will also provide a means for you to be able to view data. Apart from tables, data can be viewed using what are called views. And again, we'll look at how we can create and manage views in SQL Server. We ended at looking at how to create indexes. And I want to pick it up from there. First of all, this is the syntax for creating indexes. It is quite long and intimidating at first, but when you carefully look at the syntax, you begin to identify some of the components that we have already looked at. And I'll quickly run through those components. The first one is unique. There are times when you need to create a unique index, which will work as a unique constraint. In other words, unique creates an index where each row should contain a different index value. Okay. Clustered specify that the type of index you want to create is a clustered index where data is sorted in the index on the index attribute. In other words, the data in the table where you have defined a clustered index is going to be physically organized, arranged according to the clustered indexed attribute. Non-clustered means that you want to create a non-clustered index to be able to use in that table on that specified column. Non-clustered indexes, like we saw last time, do not change the physical organization of data, but they do instead create a logical arrangement of data ordered according to the clustered, to the non-clustered index. Again, this is to speed up the process of accessing data. The next component of the syntax is the index name. When you're creating indexes, you need to specify a name, and this name should meet the rules that applies to identifiers in SQL Server. You also can create indexes on a table or on a view. So if you are creating an index on a view, then you have to specify the name of the view. If you are creating an index on a table, then you have to provide the name of the table for that index. Column is used to specify the column or the columns on which the index will be created. I need to emphasize, indexes can be created on a single column or on multiple columns. So you need to specify the name of the column or the columns on which the index will be created. Specify that the columns as that you have listed are non-key members of a non-clustered index. And on partition, schema name is used when you need to create index on partition tables. And again, we are going to have time to look at how to create partition indexes. On file group name, that's why you specify the file group. Again, we did look at file group in an earlier lesson. We looked at what it is, how to create it, and so on. On default, specify that the index will be created on the default file group. And there are a few more other options which I will not go through at this point. A few guidelines for creating indexes. The first one is you must create clustered indexes on columns that have unique or not null values. That's why primarily these are created on primary keys, because a primary key field is going to have unique values and it's not going to allow null values. Okay. The second guideline is that do not create an index that is not used frequently. It takes a lot of effort to create indexes and maintain them. So you only create indexes where you really need them. Next is you can create a clustered index. You should create a clustered index before creating non-clustered index. The reason is this, that clustered index will change the physical arrangement of data in the table. So when you're creating indexes, it's advisable to start by creating clustered index before you begin creating non-clustered indexes.
Okay.
The last point is you should consider creating non-clustered indexes on all the columns that are frequently used in predicates and join conditions in the query. The simplified syntax for creating clustered index is as follows. You use create clustered index followed by the name of the index and the table on which it's going to be created, as well as the columns. By default, if you do not specify whether it's a clustered or non-clustered index, a non-clustered index is going to be created.
Okay.
Managing indexes. There are different activities that are involved in managing indexes. These include disabling indexes, enabling indexes, renaming indexes, dropping indexes, and optimizing indexes. Before we continue, I want to look at a few examples of how you create indexes. So I'll switch to my management studio. Again, if there is a question, feel free to notify me and ask so that I do not leave anyone lost. For the first example, I'm going to use this table. I'm going to go to the database, which I've named DemoDB3. That's the one I'll use for my demonstrations. In this database, we have a number of tables. I just want to show you the structure and the relationships between the tables. So I'm going to open my scripts.
Okay.
Okay. So I start by creating a table that I'm going to use to illustrate how to create clustered indexes. And I'm going to switch to this database. In this database, I have a number of tables, and let me just show you the structure of the database.
Yes, sir.
Okay, sorry, my database is not responding. Um,
Okay.
okay. So I use the database called demo DB3.
Okay.
And I'm going to use the table called customer. So I'll just use a select statement to show you the what information is in the table called customers.
Okay.
So in this table, I have a column called custom code, custom name, custom city, working area, custom country, grade, opening amount, receive amount, payment, outstanding amount, phone, and agent code. Okay. So I'm going to use this table to create a clustered index. Now, if you go to the database, you notice that the customer table is there, and in this table, I have some primary and foreign keys defined in it. And so naturally, this one has a clustered index defined on it. Okay. So what I'm going to do is I'm going to copy that data from customers into a new table, and then I'll create a clustered index on it using the select statement. So I say select all the columns into a new table, which I'm going to call customers 2. And this is coming from a table called customers.
Yes.
You're not able to get me.
No, I'm getting you.
Okay.
Yes.
Mercy, are you able to get me?
I'm able to get now.
Okay, that's good. Okay. So I want to copy data from a table called customers into a new table. And that's the one I'm going to use to illustrate how to create a clustered index. So that's my statement there. Select all the columns into customers 2. This is the table in which I want to copy the data, and the data is coming from a table called customers.
Okay.
Okay, so again, I can refresh the tables. So that's my new table. And what you'll notice is that it doesn't have keys. The keys have not been copied. So if you go to indexes, then there's nothing there. Okay.
Yes.
So I'm going to start by creating a clustered index on the customer code. So according to the syntax, we'll say create. So I'll say create clustered index, and as just a conversion, I will say CIX for me to be able to tell that this is a clustered index. I'll follow this by the name of the table, which is customers 2. And then I'll put the column on which I'm going to create the index. On customers 2, open bracket, and I say cast code. if I do not indicate that I'm creating a clustered index, by default, SQL Server is going to create a non-clustered index. So,
Okay.
particularly if I'm creating a clustered index, I have to make sure that I state that I'm creating a clustered index.
Okay.
Remember also, we say that you can only create one clustered index per table. So once you have created a clustered index on a given table, any attempt to create another clustered index will result in an error message.
Okay.
So I've created a new clustered index, and this is the one which appears there. So it's going to cause the table to display the data in such a way that the rows are going to be sorted in order of this column. If I create another table, I create a simple table, so table employee. Okay. Now, if I insert into this table a student for Pew Pew, with a number, say 101, and the name is
Sir, the
Felix.
table is Pew Pews, not Pew Pew.
Thank you. Pew Pews.
You're welcome.
Felix. And then I said date of birth is 1st January 2000. Let me say the student number is 170. Okay. So we have one student there. Now, if I add a second student as with a number 110, and this one is Betha Mape. And date of birth is 1999, December 16th. Again, if I view the contents of my table, I'm going to see that the data is going to be entered to be displayed according to the way I'm entering it. Okay. Then I'll go ahead now to create an index, a clustered index. So I'll say create a clustered index, and I'll give it the name. This is on Pew-Pew's table, and Pew-Pew's Pew-Pew ID on Pew-Pew's. So Pew-Pew ID. Okay, so I've listed the name of the index that I want to create. Then I indicate the name of the table, and inside the brackets, I put the name of the column or the attribute on which I'm going to create the index. Okay, so I've created one index for this table. And that's the index I've created. And as you can see in brackets, it's a clustered index. Okay.
Yes, sir.
So I'll go ahead and refresh so that I can see the data in my table. So I can see that now the data is being displayed in order of the column on which I've defined the clustered index. So what we are saying is that clustered indexes have one important characteristic. They change the physical arrangement of data in the table.
Yes.
This is one characteristic which distinguishes clustered indexes from non-clustered indexes. Non-clustered indexes are not going to change the physical arrangement of data. Instead, an extra virtual table is created, which will then be sorted in a logical order. But the physical table is going to remain the same. Okay. Now, once I've created one clustered index, remember we said that one of the guidelines for creating cluster indexes is that create a clustered index before you create non-clustered indexes on a given table. Okay. So I can now proceed to create non-clustered indexes on this table. So I can say create. If I do not specify that I want a clustered index, I just say create index. I'm going to end up with a non-clustered index. So if I refresh, I have created a non-clustered index, and that's the name. In other words, we're saying by default, the non-clustered index is created when you use the create index statement. And if I go back and search, use select statement, you see that the data will still be arranged according to the clustered index column. I can add another student. Maybe this one, date of birth is 1998. October 24th. So we have our table with two indexes, one clustered index and one non-clustered index. We can have multiple non-clustered indexes on a given table. So for example, I can create another index. If you have to use the word non-clustered, just remember it has to be written as one word without hyphen in between non and clustered.
Okay.
Pupils. On this one, I'll put it on pupil name on pupils. Non-clustered index. So I can go ahead and refresh the tables. So now I have two non-clustered indexes and one clustered index on this table. Okay. Again, I can create another index on a different table. The table I want to use is this one on customer city, which is this column. Okay. So I'll go ahead. I'm using the second column, the second table of customers. So, and that's the name I want to give it. It's going to be NIX customers. Map for completeness sake, I'll put it to there. Okay, so When I refresh, I have a non-clustered index created on this table. Okay, so that's how you create clustered and non-clustered indexes. Any questions? The indexes are going to have the default settings. That is, they're going to have the default schema. They're going to be as attached to those tables that I've created. There is a third type of index which I don't want to look at, but if you want, you can check it. This one is a unique index. What it does is when you create a unique index, it's going to create a unique constraint on the column that you have specified. So all you need to do is to specify there that you want to create a unique non-clustered or just unique index and give it a name and the column on which you want to create there that index. Okay. So far, I've only created indexes on one table. We can also create indexes on more than one column. So for example, if we are going to have a lot of search on customer city and country, you can join them together and form a clustered index on these two columns. Okay, so the syntax is the same. I start with clustered. Since I have not put the type, I'm creating a non-clustered index. Non-clustered index on a table called customers 2. And it's going to be on country and city. And there, I put the columns or the attributes on which I'm going to define this index inside the brackets.
Yeah.
So we have created a third non-clustered index defined on two columns, the customer city and customer country. Again, I need to say this. The purpose of indexes is to speed up the search for data in a given table. So you normally want to create indexes on columns where it is convenient to do a search. For example, date of birth is one column that you're likely to have a lot of search. You want to look at students who were born maybe between a certain date and another date. So you can speed up the query by creating an index on that column.
Okay.
Okay, so we said that managing indexes involve these activities. You can disable and enable indexes. You can rename indexes. You can drop, that is delete indexes, and optimize indexes. When an index is disabled, users are not able to access it. In other words, it will not be available to the users. Okay.
Okay.
If a clustered index is disabled, then the data in the table is not going to be accessible to the user. So you need to bear in mind that. Okay. So
Okay.
when you disable an index, then the user will not be able to access the index. In other words, it's not going to have any impact on the speed of accessing data. But if that index happens to be on the primary key field, then the user will not have access to that data in the table. When you disable an index, data will still remain in the table, but it will not just be available to the data modification language operations. So you will not be able to perform any of the DML operations on that index until you either drop the index, that is delete it, or rebuild it or enable it. And
Okay.
to do that, you can use a number of commands. The first one is if you want to disable an index, you use the alter index statement with the disable clause. If you want to enable the index, you can also use the alter index, only that you have to use the rebuild clause, or you create the index and add this clause so that it deletes the existing index in place of the new one. Okay. So there are two ways of enabling the disabled index. Either you use this statement or you use this statement. Okay.
Okay, sir.
Sorry, sir.
Yes?
I wanted to find out, sir, on the changing the alter, the create index with drop existing. Is it fine if the underscore isn't between the drop and the existing? Or is it a must that it should be there, sir?
Sorry, come again. I didn't get your question.
So I'm saying the create index with drop existing. I wanted to find out between the
Yes.
drop and the existing, sir. Is it fine if the underscore isn't there, or is it a must that the underscore should be there? That's what I was trying to find out, sir.
It has to be typed exactly as it is, because this is
Okay.
being treated as one word. It has to be there. The underscore has to be there.
Oh, all right, sir. Thank you, sir.
Okay. Okay. So I go back to Management Studio, and so I have created some indexes. So I'm just going to be able to disable them and enable them so that you see the statement. But for example, we have this index, so I can so to disable that index, I need to use author index, then the name of the index, and then the table, and include the keyword disable. Okay.
Yeah.
Of course, once you do that, the index is still going to be there, only that when executing queries on the table, the database engine is not going to make use of that index. It's as good as it's not there. Okay. Once I want to use that index, then I have to use another author statement where I say author index, then the name of the index, the table on which, and I have to include the word rebuild. Okay, so I need to check, did I miss the name of the index?
Yes, on the NIX customers.
Customers,
missing.
yes. Okay. Okay. So I've enabled, then after that, I can use the index during the search to speed up the process. Okay. Another aspect of managing indexes is to be able to rename indexes. And for that, you have to use a stored procedure, which comes with a Microsoft SQL Server. So for example, I might have this index. As you can see, this is from the AdventureWorks database, sample database. This is the schema, human resources, that's the name of the table, followed by the name of the index. And this is the old name of the index. After the comma, I have to put the new name for the index. Then, and after another comma, I put index to indicate that I want to rename an index, not a table, not another object, but an index. Okay. Okay. Again, let's go back to Management Studio. I think I have something. So I have on this table, okay, I need to change this because I'm copying from another. What is important here is to remember that this is a stored procedure. It's a script which comes with SQL Server, and the name is SP_rename. We did come across a similar script for renaming databases, but that one had DB at the end. But for
Yes.
renaming tables or other objects, you just use the SP_rename followed by the current name of the object in quotation, comma, then the new name to assign to the object in quotation marks, comma, and then you indicate the type